So in the last video, we were talking about making this list of all possible real zeros. And what that allows us to do is to narrow down our search for the possible real solutions for a given polynomial. So that way we can find it easier on a graph. So basically the purpose of making that list is to, let me write down a few words. So making the list helps narrow down the possible real solutions you might find on a graph. So this is extremely helpful because if you make that list, you start to notice, oh, my x's are in this area. These are the numbers that I got. So that makes it easier to search for your solutions rather than just looking through the entire x-axis trying to find it, because x goes from negative infinity to positive infinity. That's a long search because that's infinitely many numbers to look at. But if you can narrow down your search, that makes it easier to locate what x is going to be and see if it's really there or not by looking at its graph. So first, let's take a look at this problem here. So we've been building up our skills to at this point here. So we've learned factoring, we've learned synthetic division, we learned how to graph things by hand, we've learned how to graph things on Desmos, so on a graphing calculator. Because what if we're given a polynomial function and we're not given a root, we're not given a factor to begin with? How do we find all the zeros, all the possible solutions, right? How do we go about starting when we have nothing other than the equation? Well, it's not actually too complicated. So what you do is you take a look at the graph and find the real solutions first. So you know that based off this equation, the highest power is 3. You know that you should have 3 x values in the end, or 3 solutions. So what people will do first is they make a list of possible roots. So this is using that formula earlier. So you're going to find the possible zeros or the possible roots. And this is where you take the constant and you put it over so you put the constant and you put it over the leading coefficient. So the leading coefficient here is a 1, the constant here is a 12. So factors of 12s is 1, 2, 3, 4, 5 doesn't work, 6 does, and then 7, 8, 9, 10 doesn't work, but then 12 does. See, 1 and 12, 2 and 6, 4 and 3, that works. So these are all the factors of 12s. So I found all the factors of the constant. Now I want to find the factors of the leading coefficient, but it's just a 1, so I know I'm just dividing by 1. So this helps narrow down my search that I'm going to be finding some sort of possible root that could be positive 1, positive 2, 3, 4, 6, or 12. So they could be plus or minus 1, 2, 3, 4, 6, or 12. And so I got these numbers by taking the top and dividing it by the bottom. So this helps narrow down my search when I graph. So the next thing to do is to check the actual graph. And so this is where you'll need Desmos or a graphing calculator. And we're going to plug things into the graph here. I'm going to use Desmos since a lot of people are more familiar with it. So let me scroll this down a little bit. So what I'm going to do is type in my equation that I have above. And so this is x cubed. And remember, if you want a cube, you need to use shift 6 to have that exponent. And then I'm going to type in 3. And then I need a plus sign, so shift plus. And then 2x, then shift 2. So this is what I have so far. Now I need to come down. So I'm going to use my arrow key to come down. Then I need a minus sign. And I need an 11x. And then a minus 12. So here is my equation. Let me make sure everything matches, and it does. And so what I'm going to do is kind of zoom out to kind of have a better look at what my graph looks like. So you can zoom out using the buttons on the side. So plus sign means zoom in, minus sign means zoom out. And so when I zoom out here, I start to notice that this side's going down, this side's going up, but there are 1, 2, 3, 3 x-intercepts that I actually see. So I'm gonna kind of pull in closer so I can see where it hits. And it looks like it hits it at -4, at -1, and then at 3. So I'm gonna pause my video there and put that to the side for a bit. And what I want you guys to notice is that -4 is actually on my list. It's right here. So when I checked my graph, it looks like the real solutions, actually let me put that here, real, so my real roots end up being x equals -4, -1, and +3. So these were the x values that we found, and they are all on my list. There's -4, +3, and -1. So this list really does help kind of narrow down my search. So if I didn't have a graph that was very good like this, like Desmos, that helps me zoom in and out, then maybe I could just check all these values and see if it actually hit one of these x values. And so I found 3 solutions, and this equation only has 3 solutions because the highest power is 3. And so I actually, turns out, found all the solution on my graph. And sometimes that just happens. Maybe all my solution happens to be real, and I can find them all very quickly on a graph. So this one was pretty quick. So first you want to find all the possible roots. Using that formula, you'll list out all the possible x values that it could be, and then you're going to use your graph to find the possible solution, and you can use your list to help narrow down your search. So I always recommend to make this list because it helps narrow down your search better. All right, so I'm going to stick this to the side here, and we're going to continue with the next one. So from here on out, I'm going to be using Desmos to graph all of these functions so I can check the graph and find the real roots. So with this next one here, I have x to the 4th power, so I know that there should be 4 solutions. So first, let's go ahead and write out our possible roots that we could have. And so it looks like my constant here is 18, and my leading coefficient is a 1 again, so that makes things much easier to do. So plus and minus, let's see, factors of 18. So 1 divides into it, 2, 3 also divides into 18, 5 doesn't, 4 doesn't, 6 does, 9 does, and 18. And I think that's it. And then on the bottom here, I have the leading coefficient factor, which is just 1. By the way, you can do your rainbow matching to see if you have all the factors, like 1 times 18, 2 times 9, 3 times 6, and that completes my rainbow. So from here, I just need to divide all of these numbers by 1 and then put a plus and minus in front. And some people just skip this part. That is perfectly fine. I just find that this does help kind of pull everything together. If I were to get stuck, I can always, come back to making a list and helping me narrow down my search. So the next thing I want to do is check the graph. And so I'm going to graph this on Desmos and see where it hits. And I'll write what the picture looks like here. So I'm going to type this in. And this graph is pretty interesting. It looks like it hits it at -3 and 2. So here and here. And then another one at 1 and +3. And so the graph kind of looks like this weird W shape. It goes up at the beginning and then comes back down and then goes back up again, kind of like that weird W shape. And so from here, I can tell that the real roots, or the roots on the graph, shows that x equals -3, -2, 1, and 3. So I'll list those out and see if they show up on my actual list here. So -3 does show up, so does +3. So both of these show up. -2 and 1 also show up. So in this case, all of these show up on my list. And so I found my solutions. By the way, not all of these could be solutions. They're just possible solutions. But when you find them on the graph, you can kind of double check that those are the solutions with your list. All right, so it looks like I found all 4 solutions. So that is it. I found them all using the graph. So it turns out all of them are real solutions just using the graph. All right, so let's move on to C here. So with C, I have x to the 4th power again. And so I'm going to start by making my possible, let me do that in pink, possible roots. And it looks like my leading coefficient is 1 and my constant here is 6. So thinking about my factors here, so the top will always be the factors of your constant. So factors of 6 is 1, 2, 3, and 6. 2 times 3 is 6, 1 times 6 is 6. So these are the factors of 6, and then factors of 1 is just 1. So it looks like my list isn't very long. If I divide, I just have plus and minus 2, 3, and 6 as my list. So not very hard to search for my solutions. So now I'm going to graph this on Desmos and see what I get. And I'm going to just do a rough sketch to show you guys what I saw. And I highly recommend that you do this too. And so that way you practice Desmos and get a real good feel of how to use it. All right, so from here, it looks like my graph hits it at -2 and +3. So it looks like I only found 2 solutions. So it hits it, it kind of looks like this weird W shape again, but it only hits it in 2 spots on the x-axis. So for real roots, it only hits it for x equals -2 and +3. -2 was on my list, and so was +3. So that's good. The only thing is there are 4 solutions here since the highest power was 4. So I'm missing 2 solutions. And in order to get the other 2 solutions, I have to use synthetic division, because now that I have some real solutions to work with, I can just use these as my roots to break down this polynomial to find the last 2 solutions. So remember, it doesn't matter which one you start off with. I'll just use the first one, -2, as the first one to use for synthetic division. So usually, sometimes you won't find the solution, so you'll have to use synthetic division to find the rest of the solutions. If you run out of paper, feel free to go ahead and grab another sheet of paper and just continue on. So I'm going to rewrite the function here since I can't see it anymore. So I'll just copy it down so we can see it together. And so I'm going to be using x equals -2 first. Actually, how about here to the side, I'll probably just list out all my x's that I found. So I found x equals -2 and x equals +3. All right, so it looks like I'm going to be using -2. And remember, this is a root, so we can automatically put that into our box here. We don't have to set anything equal to 0. And then we just want to label our exponents. And so we have 1, -1, -5, -1, and -6. Let me just double check. So that's a 1, a -1, a -5, a -1, and a -6. So from here, we always pull down our first number, and then we multiply the bottom numbers with the number in the box. So 1 times -2, -2, and then we always add vertically. So -1 plus -2 is -3. -3 times -2 gives me a +6, and -5 plus 6 is going to give me a +1. 1 times -2 is -2. Then if I add -1 and -2, I get -3. And -3 times -2 gives me a +6. If I add, I get 0. And that I should get 0 because I've already checked with the graph here that this is a possible solution. So this should have divided in evenly, and it does. And so I have the rest of my equation now, which is my constant, my x squared, my x cubed. And so what I've done is broken down this equation into a lower power. And so this allows me to factor it easier if I can. So let's take a look at what I have left over. I'll write here to the side. I know I'm running out of room here. So to the side here, I have x cubed minus 3x squared plus 1x minus 3. So I've written this equation to the side here. And remember, we always set this equation equal to 0 because we're solving for x. So what I'm trying to do is factor this guy, or if I can't factor it, I'll just use x equals 3, this root, to use another synthetic division to break down the power, furthermore to make it easier to factor. But I think I actually can factor this. It's 4 terms, and this is x to the 3rd power, so I could try to attempt to use grouping first. If I were to do grouping, let's see if this works. Sometimes grouping doesn't work. We just have to try first. So it looks like we would take out an x squared from the first parentheses. And so we would have x left and then a 3 left. This one here, I can't take out anything. X and 3 don't have anything in common. All I can do is probably take out a 1. So I'll put a 1 in front, but that's all I could do. But then I noticed both of them have x minus 3, so I could factor an x minus 3. But that means I'm left over at x squared in the first term and a plus 1 in the second term. So I have x squared plus 1 left. So I am able to factor by grouping, which is great because I can set both of these factor equal to 0 and probably find my, my other solutions that I might be missing. So from here, I'll set this equal to 0, x minus 3, set it equal to 0, and x squared plus 1, set that equal to 0. And then I need to solve for x, so I'm just going to try to get x by itself. Now the first one, I noticed that if I add 3 to the other side, this is x equals 3, but it's probably this solution here that I just found. So I just refound this solution. Let's see what I would get if I were to subtract over the 1. So this would cross out, x squared comes down, and this is negative 1. And so I would have to take a square root to try to get rid of the square. X comes down, the square root always has a plus and minus. Square root of 1 is 1, and then I need an I because this is a negative under the root. So that leads me to x equals plus and minus 1i. So it looks like my solution is x equals 2, x equals 3, and then I don't need to reuse this because I already have this solution. And then it looks like I have x equals positive and negative I. So let's write down all my solutions that I found. So the 2 that I found on the graph was negative 2 and positive 3. And then I found positive 3 again using synthetic division, so I don't want to repeat that one. And then my other solutions that I found positive 1i and negative 1i. And so that makes 1, 2, 3, 4 solutions, and my equation did start out with x to the 4th power, so there should have been 4 solutions. And there we go, we found them all. So that one took a little bit more work. Some people even go about doing this where they'll use synthetic division with the negative 2, and then they'll do another synthetic division with 3, breaking the power down, and then trying to find the solution. And that also is very possible, probably would have made it a little bit easier too. So nonetheless, we still found the solution, but you kind of can see the process. You have to find the possible roots to help narrow down the search on your graph, and then use synthetic division if you didn't find them all on the graph. All right, so part D here is x to the 5th power. So this one's a lengthy problem. So if you're someone with big handwriting, I recommend maybe doing this on a separate sheet of paper because you might not have enough room. Like I seriously will go off the page trying to do this problem. So fair warning. So first off, let's do find the possible roots. So finding the possible roots won't take us too long because it looks like our leading coefficient, again, is a 1. And our constant is a 36. So 36 has a few combinations you can work with. So we got to put a plus and minus. So 1 goes into 36. 2 also goes into 36. 3 goes into 36 because of 9. 4 also goes into 36. 5 doesn't, but 6 does. And then 9 also does. Okay, let's see. 6 times 6, 4 times 9, 3 times 12, and then what else am I missing? Let's see, 2 times what gives me 36? 18, I believe, and then 1 times 36. So you'll notice that oftentimes I'll try to list out all the lower numbers, and then once I get stuck, I think about like what do these numbers multiply by, and that will help me figure out the higher numbers. And then the factors of 1 is just 1 for the leading coefficient. And so I can see that this is going to be my list of possible factors. I think we've done this enough to realize if I divide this by 1, I'll just get plus and minus of these version numbers. So I think I'm going to skip this part, but I like to make the list so that way I can see what I am dividing by. But in this case, I'll just move on to the next part here. You can definitely write out all your list of numbers, but I'm just going to skip it because I already know that all of this divided by 1 is just itself. So I can clearly see what the list is going to be. So now I'm going to check the graph. And so this graph, when I type it into Desmos, I actually don't find all 5 solutions. So that means I have to go find all of the imaginary ones that I don't see. So there are 3 solutions that it hits. So it hits it at -3, -2, and +3. And let's check that with our list here in a moment. So this is what the graph looks like. So my real roots end up being x equals -3, -2, and +3. And they do show up on my list. So I do have a plus and minus 3, and then a 2 also shows up on my list. All right, so that is my graph. I found 3 of the solutions, but this equation here, let me rewrite it down here below. So my equation is x to the 5th plus and minus x to the 4th minus 9x to the 3rd minus 5x squared minus 36. So this is x to the 5th power. I only found 3 of them. So that means I still have 2 solutions left, and those 2 solutions are imaginary. So I have to figure it out algebraically to find the answer. So first off, I am going to take one of these solutions and use synthetic division and break down this power so it becomes easier for me to find x. So I'm going to just choose a random one. Let me do 3 first since it's the only one that's positive. Maybe that'll be easier to start us off. It really doesn't matter though. So I'll do +3 as my root, and then I'll list out all the powers. Okay, so it looks like I'm missing x to the 1st power here, and I'm going to put in my coefficient. So my x to the 5th is a 1 for x to the 4th, a -9 for the 3rd, and then -5, 0 for x to the 1st, and then a -36. So just gonna you can fast forward this part, but I'm just going to do synthetic division. So 1, pull it down, and then 1 times 3 is 3. Then I'm gonna add these 2, so that's 4. So 4 times 3 is 12. I'm gonna add, and that's gonna give me 3. 3 times 3 is 9. So that's going to give me +4, and then 4 times 3 is 12. So that's going to be adding to give me 12. 12 times 3 is 36. So of course, this ends up being 0 for the remainder because this was a real solution that I found, or 3 was a real solution that I found on the graph. So I knew that that had to be a solution. And so this is what I'm left over with. And what we're going to do is take the leftover equation and we're going to do synthetic division again to break it down. So this is now x to the 4th, x to the 3rd, x squared, x, c, the constant, and the remainder. So really this equation is going to be 1. You can rewrite the equation if you like. So here is my equation. So last time I used x third. I think this time I'll do -2 maybe. Doesn't really matter. So -2. And then I'm going to list out my, my numbers here. So since my x's are just on top, I'm just going to put the leading coefficients. So I have a 1 for x to the 4th, a 4, a 3, a 4, a 12. So I'm just being a little bit lazier, and I'm just writing down the labels. Since they are already up above my numbers anyway. So I have a 1, I have a 4 for x to the third, I have a 3 for x squared, a 4 for x to the first, and that constant is a 12. So from here, I'm just going to drag down my numbers. So 1 times negative 2, negative 2, and I'm going to add. So what I'm doing right now is using synthetic division to break down this exponent to the third power. So that way I get closer and closer to being able to factor it or solve for x. The lower the power, the easier it is to solve. Anything that's like to the fourth power or higher are extremely difficult to solve by hand. So that's why we're breaking down the power to something we understand. 2 times negative 2 is negative 4, so this makes it a negative 1 if I add. Negative 1 times negative 2 is a positive 2, so that will add to be 6. And then 6 times negative 2 is, of course, negative 12. So when I add them, I'll get 0. And again, my remainder shows that this negative 2 is a real solution. So this is a constant x squared, x to the third. Now I'm down to x to the third. So I could try to factor it at this point, but then I start to notice, let me write this over here for a sec. So this is what I'm left now. So my function is 1x to the third plus 2x squared minus x to the first and a positive 6 as my constant. So I was going to factor this by grouping, but then I noticed this is a 2 and a 6, and I know this is not going to work to factor by grouping. It's just not going to have anything in common. But if you don't see it yet, you are more than welcome to set this equal to 0 and try to factor, but you'll realize you'll get stuck. So this one's just not possible to factor by grouping, just because I saw that this was a 2 and this was a 6, and I noticed that they're not going to have anything in common when I try to group. So instead, I'll just do another synthetic division. I haven't used, I think x equals negative 3, so I might just do that one next. It's my last one. And by then, I'll have broken this down to x squared, and that will make it much easier to solve. So I'm going to put down the coefficient. Again, I'm just being a little bit lazy and just writing down the numbers this time, but I'm making sure that they are in order. So this is x to the third, x squared, x to the first, and then the constant. So I'm going to bring down the first number, 1 times negative 3, negative 3. If I add, that's going to be negative 1. And then negative 1 times 3 is positive 3. So if I add, that's 2. 2 times negative 3 is negative 6. And of course, that ends up being 0 because negative 3 was a real solution anyways. So there's my constant, my x, and then my x squared. So I finally get down to this as my equation. So x squared, 1x squared minus 1x plus 2. So I'm going to set this equal to 0 because 1, I can't do any more synthetic division because I've used all up my numbers, my roots. So what I could do next is try to factor, but then I notice this number here is a 2 and this is a 1 in the middle. And there are no possible combinations for this to be possibly able to factor. So I can just tell right now I'm not able to factor this. So I'm going to have to use quadratic formula. And you could try to factor this, but I think this one's just not factorable. So my a here's a 1, my b is a negative 1, and my c is a 2. So quadratic formula always works to help you find x. So if you need the quadratic formula, I'll write it here to the side in case you don't remember the formula. So it's x equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. So feel free to use that if you do not remember. So it looks like my x is going to be negative 1, my b, plus and minus the square root of b squared, so negative 1 squared, minus 4ac, so 1 times 2, all over 2 times a, which is 1. So if I try to clean this up, the two negatives will become a positive, plus and minus will drop, and then cleaning up inside the root here, there's a negative 1 that gets squared, so that becomes a positive 1. And then 4 times 1 times 2 becomes an 8. and I'll just drop down that negative sign that's between them. The bottom ends up just being a 2 because 2 times 1 ends up being a 2. So let me scroll this down. So you guys can see this problem is quite hefty. 1 minus 8 gives me negative 7. And so from here, if I bring down x, I can see I have a plus and minus. I'll bring out an I so I can write this as the square root of 7. So there's a negative sign, so I know there's imaginary number. Square root of 7 doesn't break down, so I'll just keep that there since 7 is prime. And there's nothing more I can do. There's a 1 here, a 2 here, and an I. They don't have anything in common. I can't simplify the square root of 7 any further than that. So this is my final answer. Oh my gosh, that took a lot of work here. So I basically just found the x for this solution. Look at all that work there. Yeah, I'm definitely going off the page. So let's write out all the x's for this solution. So remember, this equation is x to the 5th power, right? So we're going to have 5 solutions, and let's list out all of them. So the first 3 solutions that I found on the graph was -3, -2, and +3. And then after using synthetic division, I got to this quadratic, and the quadratic led me to this imaginary solution. So x equals plus and minus, so that counts as 2 solutions, the square root of 7 over 2. So you can probably split this up as one that's positive and one that's negative, but this counts as 2 solutions here. So there's 1, 2, 3, 4, and 5. So that is all my solution. Whew, that was a lot of work there. But I hope you guys found this video helpful. Ask your teacher if you need help with any of these concepts. Bye, guys.